All right, I want you to do this next one on your own. I think you can handle it. All right, so we're talking about it in an inverse sort of way. They're like, okay, if we were talking about the inverse, f to the negative 1 of a equals 1. So we're saying, okay, for the original function, if I had an input of 1, my output would be a. So rewriting it like this, rewriting it not as the inverse, but instead as the original, when you're only given a graph of the original, is a good way and a good strategy to help you be able to figure it out and process it. So that means that I'm going to my x value of 1, go up to my graph, find that point, and then go over. I know that that's going to be 1a. And I see that a is going to be halfway between 2 and 4, which is 3. So a equals 3. When you have these points, we could also go in here and now graph the inverse function, because I know it's going to be a line, because inverses of lines are going to be lines. And I now have some points, right? I've got my original point here, or one of my points, 2, 5, which, as we talked about in the examples or the explanations up above, would become, for the inverse, 5, 2. I could graph the inverse of this point. The inverse of this point is 5, 2, which would be like right here and then right here. So that would be 5, 2. I could also take this point, which is now, the original was 1, 3, but the inverse would be 3, 1. So 1, 3 becomes 3, 1. You can do that with any of these points. You have found a bunch of them. I don't think we can fit 9 on the x-axis, but if I found another point here, for instance, this point right here, that's the point 0, 1. And so the inverse of that would be 1, 0. So I just go find where that is and plot it. Graphing this inverse looks something like this. And so that's what the inverse of this line looks like. Try and look at now our two graphed examples of inverses. You don't have to write anything down right now, but I do want you to just kind of think about it. What do you notice about them? There is a pattern here. What's the relationship between the graph of the original function and its inverse? Think about it. Okay, example 2. This is more of an IB type question where we're given some sort of information and we have multiple problems that we have to solve with it that all lead from one to the next. They have a logical following that help you with the next one. This is not a very applications type of problem because it's not a real world application. So this is really just focusing on the mathematics of it and not really like the word problem-y part of it. So just keep that in mind that this might not be an applications IB problem, but this is definitely an IB problem in regards to these like multiple steps where one logically follows to the next and results in this, in the ultimate end goal of what this problem is. So we are considering this linear function. The graph of h intersects the line y equals x at point P, and we want to find the coordinates of P. Where two graphs intersect, they don't even have to be lines, it could be two parabolas, it could be a circle and a line, it could be anything. Where two graphs intersect is a solution to a system of equations. When two graphs intersect, there is exactly, with lines, it's one point. It depends on what type of graph we're talking about, but there's at a point where these two graphs intersect is a point that fits on both of those equations. On the first and the second equation, that is the only point where they intersect. That is the only point that works for both. If it's two lines, if it's like two parabolas, it could like intersect at two places, right? So if we're talking about two lines, though, it will only intersect at one point. So when we're talking about that, we can solve for this in using systems of linear equations. We can solve for it by graphing, or we can solve for it knowing what we know about systems of equations. If we have y equals x and we have y equals 2x minus 5, solving for systems of equations means that we plug in one variable for the other and solve by hand, right? So I would set these two equations equal to each other and solve that 5 equals x plugging that back in to find y. If x equals y, then 5 is also y. So I can do that by hand really quickly. If that is something that you know you'll get stuck on a test, you always have your calculator, right? And so you can solve for this by systems of linear equations, or you can graph. So if I wanted to do y equals x, graph it, boom. And then if I wanted to do y equals to x minus 5, we can see where that point of intersection is. Remember that for anything that we're doing, if any type of analysis or anything on our graphing calculator menu is the first step, we want to analyze the graph and we want to find the intersection. Pressing enter to give us this sort of like neighborhood that we're focusing in, and it gives us the 0.55. Right, so there's many ways that you could have solved for that point by graphing, by systems of linear equations, using the application, which we'll talk about, I'm sure, at some point, on your calculator, or to solve it by hand, because this is really simple. This is about as simple of a system of linear equations as you're going to get. So there's the first answer. Then it says point Q. Point Q lies on the graph of H, and the x-coordinate of Q is 1. So we know that we have a point Q, we have an x-coordinate of 1, and we have no idea what the y-coordinate is, but we want to find it. We know that Q lies on H, which means that we can plug in 1 for x and find H of 1. Go ahead and find H of 1 on your own. H of 1 is equal to -3. So the y-coordinate of Q is -3. I'm going to write this as the point 1, -3 for my answer. So it says hence. When you see the word hence in IB, it's saying, hey, you've just done some work. Take this work and use it. So it says hence, write down the coordinates of 2 points that must be on the inverse. Well, if you have 2 points that you know are on the original, you know that finding inverse points is just taking your original points and flipping them. So go ahead. We know that one of them, 5, 5, stays 5, 5. We'll talk about why, and it's specifically because of the fact that it lies on that line. But that is 1 point. Go ahead and find the other point that lies on the inverse. If 1, -3 was on the original equation, then on the inverse, we would have -3, 1. So there we have 2 points that must be on the inverse because we know that the flip of them is on the original. So then it says, find the equation for the inverse of H. Remember at the beginning of these notes, I said, you will never be asked to find the equation of the inverse. Well, this is a situation where you can easily find the equation of the inverse because it's logically following from one step to the next in the IB way of that A leads to B, B leads to C, C leads to D. It says, hey, you have 2 points. Find the equation of the inverse, which is a line. Can you find the equation of a line given 2 points? Hell yeah, you can. Go ahead and do it. So using what we know, we have these 2 points. We know that we need to have a slope for our line. So I go ahead and calculate that slope real quick. 1 minus 5, -3 minus 5 is -4 over -8, which is +1/2. Plugging this into my point slope form, which is always the form we want to use at the beginning. We do y minus, and I'm going to use 5 because that's simple and straightforward, and I don't have to remember which one is y and which one is x, so I'm just going to use 5. Isolating for y, which is normally how we want to answer our question anyway, we get y equals 1/2 x minus 5/2. I've distributed the 1/2 to both of these, and then I am adding 5 to both sides. You can use your calculator to combine those. If you do not know how to get a common denominator and put them together, you can use your calculator to combine them, and it'll tell you what it is. And it is 5/2. And that is the equation of our inverse, because you know how to find the equation of a line when you have 2 points. So it's logically following from one step to the next. There is a process that you can follow for finding the equation of anything, for finding the inverse equation of a cubic. There is a process that you can follow to get the next cubic, because if you have only 2 points for a cubic, that's not enough information to establish what the cubic function is. So there's actually like a whole set of steps that you have to follow, and you can find the inverse equation of any function that you want, but you will not have to know that. This is the only type of instance where you would be asked to find the equation of the inverse, is when it logically follows and you know how to find the equation of a line given 2 points. And it held your hand through that.